Hello, welcome to your trigonometry lesson on more applied problems. This image here is foreshadowing of something that is to come. Okay, let's begin where we always have to begin when we're talking about trigonometry, and that is soaking your toe. So we have SOHCAHTOA, just a reminder, sine of an angle is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent of an angle is opposite over adjacent. All right, let's get started. So for our warm-up, before we do applied problems, we're just going to look at some typical diagrams that you might see and where you have to solve a part of it using trigonometry. Let's begin at this one. We have two right triangles next to each other. Don't make the mistake of assuming that these are the same or congruent. They are not congruent. So your goal is to find this angle, and you must begin in this triangle because you just don't have any information here. I'll give you a hint. Find this angle first, which will allow you to find this angle, and then you can continue on to there. Let's try. Okay, so first step, definitely set up a cosine relationship here. We have cosine of angle BCA. BCA is BCA, so it's this angle here. Don't forget, when you see an angle written in this form with three vertices, the middle one tells you where the vertex of your angle is. So C is here, so that's the corner there. Anyway, we're using cosine because we have the adjacent side and the hypotenuse. We do not know the opposite side. So adjacent over hypotenuse. Remember, when you're solving for an angle, you're going to use inverse cosine. Now we have the angle of 47.7 degrees. If you're not able to get that before, think about how you can proceed now. Now that you know this angle, how can you get this one? And if you know that angle, can then you very easily get this angle? So here we go with that. We have angle ECD equals 180 minus these two. So these three angles here all together make 180 because we have a straight line here. So we just found this one to be 47. We have this 91. So if you subtract those two from 180, you'll be left with this one, which is what's being done here. And that means ECD, that angle here, is 40.65 degrees. Now that you know this angle, no more trigonometry required. Again, we have a triangle, we know one angle, we know another angle, so we can easily find this one using the same property. So 180 minus those two, and we have 49.35 degrees for that angle. So not so bad. Once you kind of got yourself out of this triangle and use some basic properties, we can get to this angle quickly. Let's try the next one. Take a look at this one. Notice this one has two triangles, but this triangle here is like, it's not a right triangle, so we can't do trig in that triangle. But we do have this right triangle, and then the entire thing is also a right triangle. Give it a try. You're looking for this angle. Okay, so here we go. I started with a tangent of ABC, ABC. So it's tangent of this full angle here. So I'm talking about the entire triangle. You can basically ignore this line here. So the full triangle, the opposite from that angle is this side, which combining those two is 12, and the adjacent is 18. So again, 12 over 18, opposite over adjacent. Solve that using inverse tan, we get an angle of 33.7. Again, that represents the entire angle here. So now how can you proceed? Again, there's a second right triangle here, and that's kind of a hint of where you can go next. So in that second right triangle, angle DBC, so now it's DBC, so this small angle, again using tangent or inverse tan, opposite 7 over adjacent, so now we're using this portion here. Solve for that angle, you get this. And now if you know the entire angle, which you do, and this portion, which you do, you can just subtract the big number minus the small one, and you can get the remaining piece right there. So that is our answer to that one. Okay, the next one looks like this. Again, notice we have one right triangle and another right triangle, and remember, well, this is what we're looking for, but remember, you cannot set up any trig unless you know two parts, one angle, one side, or two sides, or so on. So try to set up a trig ratio to get you started. So there we go. I looked at this right triangle and I saw I have two parts. So I did a sine ratio because we're looking at opposite over hypotenuse. Why not the adjacent? Because finding out this side here won't be helpful, but finding out this hypotenuse of this triangle, that hypotenuse is also a leg in that triangle, so finding that one out is definitely going to help. So solving that for x, we switch those up right here, punch down your calculator, 14.8. So 14.8 is this value here, and now you're left with this triangle where you do have this leg and this leg, so you can definitely solve for this angle. Alright, so that again using sine from this angle, opposite over hypotenuse. So the opposite side is the one we want, and we know, sorry, is the one we just got, which is 14.8, and the hypotenuse there is 14.6. Using inverse sine, because we're solving for the angle, and our answer, strange. Did your calculator give you an error in that one? It certainly does. So what that tells you in this diagram is that basically it's impossible to have 14.8 here and 14.6 here. And if you look at that and think about triangle properties, that makes absolute sense, because in this skinny right triangle here, 14.6 is the hypotenuse. And we just solved that this side has to be 14.8. The hypotenuse in a right triangle is always the longest side in a triangle. So the fact that this was longer than this hypotenuse made no sense. That is an impossible situation. So no answer for that one. Okay, try this one. Okay, so how can we begin? First of all, we have 44 degrees for this entire angle and 28 for this one. So we can right away figure out that this small one is 16, because 44 minus this 28 is 16. So now we have this skinny triangle with 16 degrees here. However, that's not a right triangle. What can we do next? Well, check it out. 16 here, 28 here, because, how did I get that? All right, here we go. Here's a horizontal line, and here's a horizontal line. These two are parallel to each other. As you may remember, when you have parallel lines and a transversal, the angles here, which are called alternate interior angles, are congruent. So that one, imagine the letter Z there. There's that big Z. That angle and that angle are the same, 28. This is helping us move forward, because if this is 28 and this is 90, we can find out this entire angle in this big triangle, which tells us this must be 46, because 180 minus that tells us this angle had to be 62, and we already had 16, so this must be 46. So a lot of work with angles first before even doing anything else there. Our goal is x, so what do you think you can do next? Well, in this one, we can set up a tan ratio, tangent of 46 is opposite this one here, BC, over adjacent 48. And that means BC is 49 when that's solved. So this is 49.7. And now set up tangent again for this entire angle here. Again, now we're looking at from this small right triangle, now we're looking at the entire right triangle. So tangent of 62 here is this side opposite the entire length, which is x plus 49, 49.7 over adjacent 48. And solving that for x, we can multiply by 48 first. Then we can subtract 49.7 from there, and we have x equals that. Calculate that, 40.6. Okay, so these are getting a little tricky. Sometimes it takes a little experimentation. Sometimes you take the wrong first step and then decide, oh, I got to try something different. But once you get used to these problems that have all these combined triangles, it's not a bad process. So keep looking at those and studying those. Make sure you know those. And there's a reason we're doing these, because a lot of our real-world scenarios end up being modeled by diagrams that have these kinds of triangle combinations to them. So here's our first problem, and we're coming back to the volcano now. Take a look at that, read that, and see if you can set this one up. Okay, so here I'm drawing a horizontal, then I'm having somebody who's standing and looking at the top of the volcano. The angle of elevation, it told us from that person to the top, is 23 degrees, so here's our 23 degrees. And then it says if the surveyor, that person who's observing, moves 750 feet closer, so if they go closer, then the angle of elevation is now 37. So again, they started there was their angle, then they walked 750 meters, they're standing here, they look up. Obviously when you get closer to something, your angle gets bigger because you're tilting your head more. So there's that 37. That's everything we know. Can we solve it? This is very similar to the last problem in this setup. So see if now you can determine the height of the volcano. So we're looking for h right here. So I'm going to call this x, I'm going to call this h, and let's see what you can set up here. Can you solve it? Okay, so I'm doing a tan ratio for the full right triangle first. So tangent of 23 is opposite h over adjacent, which is these two. Notice we have two variables there, so we can't solve that. So I'm going to look at now and say, okay, can I set something else up? Okay, let's look at the little triangle. Tangent of 37, opposite over adjacent. So now I have this equation. So now I have two equations that alone, each of them is useless because both of them have two variables. However, when you look at them, they both have the same two variables. So now we've come to something that's very common in these kinds of trig problems, which is the need to use a system of equations to combine these equations in order to solve the variables. And since they have the same two variables, we can combine them. So again, here's our two equations. I'm going to solve this one for h by multiplying by this. So notice that went over here. This one I'm going to solve for h also by multiplying by x, so the x goes there. Now I have two equations for h, so I can set them equal to each other. That thing must equal that thing because they're both equal to h, so they're set equal to each other. Now it's just a matter of doing a little algebra. Let's take a look. This part you can multiply out, so x multiplies tan and 750 multiplies that tan. We have this. Now our goal is to get all the x's on one side, so I have this and this and this here. So I'm going to take this and subtract it over to that side. There it is, so that went over there. Now I have x and x here. We can do factoring, so factor out the x from both of those. So here's the x factored out, and now it's just a matter of dividing by all this and we'll have x. So x equals this part divided by all that, and that can be punched in all in one step on your calculator to get a value for x. And that value is 967.4. So we just found out this distance. And once we have that value, we can put that in here, for example, and solve for h. So if I put that in there, I get h is this. So there's our final answer. If you got that in the beginning, that's fantastic. You have a really good grasp on trig already, and the idea of using systems is a tough one here. But if I had to help you step by step, don't worry, but there will be more problems like this. So the next one's going to use systems again. Let's see if you can set it up and solve it. So here's the problem. Please read it and give it a try, and know that you'll have to do the same process as the last problem. Let's see if you can have some success with that process. Okay, and let's check our work. So this one I worked out some years ago, but I have it here. Hopefully you can follow the process. Here's the diagram, here's the work, my two equations, and after that it's exactly like the last problem. I solve for h, combine them, solve. So take a look closely, and hopefully you followed the same process. And I'm going to leave you off with a challenge problem. This is one that most students every year when I present this one find it to be quite challenging. And here it is. So I'm going to give you time to read it and give it a try. Just so you know, this one is now in 3 dimensions because we have these poles sticking up from the ground. And it's going to use a system of equations again, but it's going to be like twice you're going to use a system and combine things twice. And you're going to have to use some Pythagorean theorem in there and trig. So try it out. If you enjoy a good challenge, you'll definitely have one here. So let's see how it goes, and I'll share the answer in just a moment. So here's all the work for that one. I'm not going to go through it step by step. This is definitely a problem that you have to engage in and take a look at all the details and do that. So take a look. But like I said, there's some Pythagorean theorem in there. There's some trig. There's combining equations here. There's combining equations again. And finally, there's an answer that can be pulled out of all that work. So definitely a challenge. I hope you were up for it. Even if it didn't go well, as you study this now, I hope you can figure it out and have the stamina, the drive, and the persistence, and the open-mindedness to go with this. So great work. See you next time.